All right, welcome back. Before we have our next speaker, I have an announcement. I have a reminder. I just talked to Quinn and Matt from SourceGraph about the live blogging, and they told me that if you're interested in being involved in the live blogging, you can have your name in front of 100,000 people. 100,000 people read the Gophercon live blog last year. Thank you. So, if you're interested in being involved in the SourceGraph live blog, which is read by 100,000 people, then point yourself in the direction of the person who whooped, and they can help you out. All right, without further ado, Florin.
Thank you. Okay, can you hear me? Good. Cool. So, hey everyone, thanks for coming tonight. Thank you for the organizers for hosting us. My name is Florin. I work at JetBrains as a developer advocate. And tonight I'm going to show you how to write a microservice in Go using the standard library in about 30 minutes or so. Let's see how we have the time. So behind me, I have the boilerplate, which is the standard hello world, right? And I'll start from here. The first thing that you generally want to do is you want to not hard code anything. So let's say we'll call this a message and that's it. Right, but microservices are usually written in something that talks to the web, right? Or gRPC if you want. So let's do something about that. We have the new mux, right? So that's how we create a new mux in Go, which allows us to do some routing, right? Then for this, we want to have a handle func, which allows us to actually define our route. And we want to take that path and translate it into some action. So let's do that. Let's say we call it on the home. And here we define a standard handler function. And let's say we want to print this message, right? We have the write operation. And then we want to convert this to a byte. Okay, so nothing fancy so far. We also want to declare a status because that's always fun to do. And we want to reply with status OK because that's nice for us to have. And we probably also want to have a content type header to help the net HTTP library actually not have to do the detection in its own, which kind of speeds up the responses, and just tell it, hey, I'm going to send plain HTTP. Don't worry about it. Don't detect anything. Right. So after we do this, we want to actually expose this on the internet and start the server. So we can do HTTP listen and serve, and we can do this on an address. Let's say 8080. Even louder? Okay, bring it loud. Yes, I think I can. Is it better? It's good? Okay, cool. So, bigger fonts. Right, so that's like our basic HTTP server. And if I want to run this right now, it's going to take a while because this one is using one of those ultra low power PC whatever chips. And it started. It doesn't write anything here. So if I want to actually do an HTTP request, I can do something like this. Actually, let me delete this, localhost, and I'm on 8080. Oops, not HTTPS. Right, so hello Gophercon, it's there, it's working. Right, what do we have here? So we have the HTTP server, but there's something missing to it. We don't have any error handlers here, so or error handling. So I'm gonna add that because we are good citizens, right? And like good citizens, we probably want to do something about it, and usually we log the message. And let's say we want to log this as a fatal error. And we want to say something like server trashed. right? And then with what message it crashed. So we handle errors in some way, right? Next. What I have here, it's like the basic core thing, right? But if I think about it, I kind of don't want to always have the handling function in line, right? So I want to move this one out. Let's say we call this the home handler, right? And actually have this in home handler, and it's still going to work. Actually, I should hide this one. Right. Another thing that we do here is that we use the log package, right? So the log package is kind of used as it is, but we can do better. We can control some of the things that we have. So we can say something like log neo, and we can say, oh, I want to log to std out. Let's say I want to have a prefix for this one, Gophercon, and I want to use the std flags, which are lstd. And I want to also see the, sorry, my keyboard layout crashed. Not part of the demo. Keyboard, oh no. Sorry about that. My computer had a bit of a meltdown in the process. Blame it on Windows. Where's the English International? Okay. Right. So I should better. I can't still. Who knows where pipe is on a keyboard?
Above enter.
Yeah. See, that's the one. Okay. I'm not gonna try anymore. Okay. I led this onto Windows. Okay, so thank you, Windows, for sabotaging a live demo. Right. So it's going to look something like this. So now I control the instance for the logger. There's another thing that I'm not doing really nicely here. I said it's going to be exposed on the internet, right? So if you use the standard HTTP package like that, chances are you haven't read the blog post from Cloudflare where they actually guide you really well on how to set some timeouts, which are pretty important. And because I'm lazy, I usually just have something that's predefined, and I use that as a template. So I define some timeouts for how long a connection can wait for a read or a write or the idle time and so on. And as you can see, I'm also defining the TLS config here. So I want to actually write the custom TLS part, which is a bit longer, right? So I'm not going to write that on my own. It's something that you can pick up from the Cloudflare blog post. It's it's exposing Go on the internet. It's pretty easy to find, and it tells you everything about all the things that I'm doing here. And if I move this statement a bit above, it's almost going to work. It asks me about the address for the service. So let's define the address here. And we'll define them as environment variables because that's one of the ways to actually expose a proper service on the internet, using the environment variables to configure the service, right? So far so good. The only thing that's left is to actually replace this function with our SRV. SRV, listen and serve TLS. And then we can say the first is the cert file, and then we have the GC key file. Right, so this one will actually launch on a TLS web server. I already have the certificates here, and if we have time, I'm going to actually launch this in a Docker container as well. But basically, what I can do now is I can go here. And because I'm not actually stopping the previous service, Sorry. So the service started, and if I do HTTPS, let's say local host 8080, it's still working. So I just made an HTTPS web server in Go in like, what, 10 minutes, right? So it's not that hard. You can also use something called Let's Encrypt to get the certificates or whatever you use in your infrastructure. But for simplicity and demo, I just generated some self-signed certificates. Right, so this is the boilerplate part. So how do we take this and actually use some proper packages? And for that, we can turn to what Peter Bergen, I hope I spelled his name right, JBD or Bill Kennedy wrote about how you can structure your Go packages in an idiomatic way, in a way that actually fit the purpose for what they are made. And something that I discovered that I can generally do with these types of configurations is that I can take the whole part of TLS configuration, the whole muxing part, the whole service itself. That whole thing doesn't really change between services that much for me. So I can take that part, I can extract it in its own function, right? So let's say new server. And because it's all a pointer, yeah, we just return everything to that. Or we can, how do you call it? We can undo a bit, and if we want more control, we can take this part out from the refactoring. So let's say we don't necessarily want to use NetHTTP later on, and we just take this part, which is generally common across everything else, and we extract it in our function, right? So now we have a new server. It's the same thing, and let's move it to its own package, because that's the important part, right? We want to reuse packages across all our applications. And I can do that, and I can say something like, okay, I want the server, and wait, I don't want to move that because I have a conflict. I want to export this. Right. So now, if everything went well, don't want to import the main project. Probably not a good idea, right? I can also choose to move my environment variable here. Or I can choose to say, this is your environment variable, right? And then, sorry. So this is your environment variable. Why am I going in the wrong service? And this is your address that you want to live at. gc addr, which is a string. So now I have the configuration there, and if I properly start reading code, it's actually going to work. So now my server creation is isolated from the rest of the code, right? And I can reuse this package over and over again because I generally kind of don't want to change anything here. I have my configuration inserted automatically by that address that I'm exposing. Maybe I want to configure later on some variables, but yeah, that's fine. I can do so, and I can pass parameters to the function. Another thing that I can also do is take this home handler here and put it in a package which actually has some meaning for it, which actually takes the idea of a home handler and transposes it to something like, let's say, a page, or in this case, a home package. The idea being, in Go, you should have a package that corresponds to a set of actions that work together to form that page, if you want. Whereas in other languages, you would use something like a model view controller layout, and then every controller would be in the same package, and then every model would be in the same package bundled together, but the view, the model and the controller would be in separate packages. In Go, you want to combine those. You want to have the model, the view, and the controller in the same package because they form an action that together provide an output. They form a singular unit of work. So let's do that. And let's say I want to have this as a home handler, for lack of a better name. And I also want to move the message. Right, so I'm using, for now, functions. But generally, what's recommended and what I found to be useful is that I want to have a structure for this. And I know it's frowned upon to have a type which is called the same as the package, but it's a live demo, so yeah, I can't come up with a better name. And let's call this home. For now, I won't put anything in the type here. And let's have a constructor function just for fun. So this one doesn't take any parameter. We return a new home. And here we return the home. Right, so with that being said, I can now take this one from here. And I can say new. I can also say, let's call it H. And let's call this handler. Right. So now my main function from a function which was maybe, I don't know, 70 lines of code, it's a bit more readable. I can understand what's happening there. I can actually see the workflow without having to enter in all the packages, because the functions have some clear names about what they are doing. And my code is separated so that I can work on it without trying to affect other packages. This also means that I can test it easier. Sorry. Right. So let's add a dependency to this. And like, let's say we want to log how long it takes us to do a request, to process a request. We would pass the logger interface to our constructor that we created earlier. We can say here, okay, you get the logger. Again, I'm terrible at naming things, so. Okay, and I have that. So now there's two ways to do this. Like I can add the logger itself, the statement and the monitoring to the handler itself, or I can create a middleware based on that. So I can say, oh, I want to wrap my handler from what I have to do here in something that actually monitors the time for me. So I can say something like this. I want to say, let's time tracking. Right, and I want to receive a handler, which is of type handler func, and I return back a handler func. So basically, that's how you create a middleware in Go. You take the input as a handler func and return that. What you do in the middle is that you do something like this. Right, so we have our writer request. Let's call them more idiomatic W and R. And now I want to say, oh, okay, I want to call the handler, right? And I want to call it with W and R, and it's fine. And let's do some monitoring. So let's say start time is time now. And defer, let's actually put this in a proper structure. So now I can just say logger dot hlogger printf, and let's say request took okay, time now sub start time. Okay, so that's how you do it. We can also say something like request to whatever page, and we can use the quoted form. And we can say here the R request URI to actually get some more information there. So that's how you do it. Like that's a middleware. Now you have a bit more control, as I said, so you can do something like this. You can do age time tracker, and then you can feed it the handler itself. So by just applying this part, you can now customize your middleware, and you can apply it on different parts of your code. What's cool is that you can have the same binary, apply different logic based on the flags you start. So for example, if you use a different environment variable to control whether the binary starts with a debug session or not, you can probably add a middleware which is controlled by that. You could also feed some additional parameters to the time tracker middleware, because that will just return the actual handler that we are interested in, or we can use more handlers to wrap things up. Right? And kind of that's it. Like we probably want to generate tests, because that's something we should do. Sorry. And let's say I want to test this function, but I'm not going to write the whole boilerplate because I don't want to really do like a table test here. I actually forgot the shortcut. Give me a second. Sorry, for me it's like 5 a.m., so... but where's the test for this one? Test on handler. Right, so kind of that's it. Like, I'm going to explain what's in here because there's a lot of code that just appeared on the screen. And basically what happens is that if you've heard of the concept of table testing, this is pretty popular. If you haven't, there's a few resources that are quite good. I think there's one even on the golang.org website. What I'm doing here is basically I create a slice of type struct, and in that struct I'm actually defining my test cases. I define the name for the test case so that it's easier to track when I actually run it. I define the input parameters, the output parameters, and what I'm expecting to happen. And the actual test case that I'm defining is contained here in this block of text. And I say something like, okay, I named this one as good. I'm using the HTTP test package, which I highly recommend having a look if you haven't already. And you can define a new request. And it's pretty straightforward. I want to do a GET request on the home part without anybody because it's a GET request. For the output, I'm actually using the HTTP test package again, but with the new recorder, which will return me a custom HTTP writer interface. No, it will return me a type which implements the HTTP writer interface type, but it's not the actual interface, and it has a few more goodies on it that I can see. I'm expecting the status OK and the message to be in the body. So I'm a bit cheating there, and then I run the test itself. One thing that you probably notice here on this line is that I'm assigning tests to itself, and I'm doing that in order to prevent a very weird bug in Go, in which the value itself, when you run the test in parallel, might not be the one that you expect it to be, might be a reference to an older value. Sorry. So this allows me to actually run the test that I want to run by creating a new variable. I'm effectively using shadowing, but for good purposes here. And then I just run the subtest itself. I create a new handler for the homepage without any logging part because I don't need that. I'm executing the handler itself, and then I say, okay, tell me what came out. And this is where I said that the test itself is interesting because when I say the out part, right, I have the test.out.code, which is the status code of the request, and I can access it. But if you normally look at the HTTP response writer interface, you won't have access to the status code once you write it. It's pretty much an interface, and that's it. You don't have access to anything behind it. Well, you could, but yeah. And then I do the body as well. I take it into a string, and that's it. So if I run this, and I wait a bit for Go to compile my stuff. Come on, Go. It's over after this one, I promise. Okay, and it's run, and yeah, all my tests are running. So pretty much that's it. Like, it's not a lot of code to now add one more test, because I can already copy this one. And let's say, instead of writing the same test, I can say, oh, I want to write a bad test, and instead of status OK, I'm expecting a not found. Right? And it doesn't really matter what else I do there, because if I run it, it should fail. So it did fail, and it tells me, yeah, okay, it failed because it expected the 404, but it actually got a 200. So adding new tests to this is pretty straightforward, and you get to see all the test cases in the same part. So you don't have to have multiple functions to keep track of them. And kind of that's it. Like, you have tests, your service runs on HTTPS, you have packages that are separated into their own unit of work. You don't have to do any work to remember all the boilerplate code that's in here to actually configure the service, because you can reuse this part. And you can define your own middleware to actually help you write exactly what you need to do. Let's say track how long it request takes, or maybe, I don't know, use some open tracing to do tracing in your code and so on. And yeah, that's it. So thank you for coming, and if you have questions, let me know.
Yeah. Any questions? Put up your hand, I'll bring the mic over. We got any questions?
If not, okay, no one?
All right, you're here all week, aren't you?
Yeah, I'm here all week at the JetBrains booth, so yeah.
Yep. So cool. Come talk to Florin.
Thank you.
Okay, so we have now 2 lightning talks.